Hey students, we're going to go ahead and go over some examples of using the combined gas law, which I showed you on the last video here. You can see it when we use the combined gas law, we're going to have two of each variable. So we could have two pressures, for example, or we could have a new volume, or we could have something that's at STP and something that's not at STP. So we want to look for those clues in the question that indicate we're going to have two of each of those variables. Now, when we do the problem, we may not have all of these variables represented. We might have just a piece or two of it. So we're only going to pick out the things that we need and ignore the rest if they're held constant. Okay? So let's take a look at this question here. It tells us that we're collecting a gas in a 242 milliliter container. So that's a volume. The pressure of the gas in the container is measured and determined to be 87.6 kilopascals. So that's pressure 1. What is the volume, so V2, of this gas at 101.3 kilopascals? That's pressure 2. We want to assume the temperature is constant. So as you can see, we only are dealing with pressures and volume. So we're only going to use the top part of that combined gas law that has P1 V1 equals P2 V2, and we can ignore the N and the T that are in the denominator, okay? So with pressures and volumes, you can use any units as long as the units are the same on both sides. So our pressure 1 was 87.6 milliliters, not milliliters, kilopascals. And our volume 1 was 242 milliliters. Our pressure 2 is 101.3 kilopascals. And we're looking for volume 2. So in order to solve here, we're going to be taking our 87.6 times 242, and we have to divide it by 101.3 in order to get V2 by itself. Since we're multiplying and dividing, our sig figs are going to be based off of whichever value has the fewest number of sig figs. So we have 3 sig figs here. So our answer is 209, because our units of volume on the left side were milliliters. Our units here are also going to be milliliters, and that is our answer. Looking at example 2, a sample of gas at 15 degrees Celsius, sorry, that degree sign looks like a 0, but it's not. So that's T1 in 1 atmosphere, that's P1, has a volume of 2.78 V1 liters. What volume, so we're looking for V2, will this gas occupy at 38 degrees Celsius, T2, and 1 atmosphere of pressure? So you can see that the pressure is actually constant. So we don't actually have to deal with the pressure this time because it's at 1 atmosphere in both cases. Now when you do these problems, remember the temperature always has to be in Kelvin. The temperature always has to be in Kelvin. So that means we have to add 273 here. So our T1 is actually 288 Kelvin. And we have to add, I don't trust my mental math skills right now. We have to add 273 to this one also, and that is 311 Kelvin. Now, because we're only worried about the V's and the T's, we can actually ignore everything else in that combined gas law equation. So we have V1 over T1 equals V2 over T2. So our volume 1 was 2.58 liters. Our T1 was 288 Kelvin. Our V2 is what we're solving for, and our T2 is 311 Kelvin. So when we solve, you're going to cross multiply. So we're going to take these numbers together. We're going to multiply those. So 2.58 times 311. And then we're going to go back and we're going to divide by this diagonal where your variable is. We'll divide by 288. So our answer for V2, we get 3 sig figs because that's the fewest number of sig figs, is 2.79. And our units are liters because on the V1 side, our unit was liters. Okay? So moving on to the next question here. A 2-liter flask, so that's a volume, contains helium gas at a pressure of, that's P1, and a temperature of 0 degrees, sorry about that, that's a degree sign, T1. What would the pressure be? So we're looking for P2 in the flask if the temperature is increased to 150 degrees Celsius. So you'll notice that it doesn't give us a second volume. That's because we're in the same flask. Our volume's actually going to be staying the same. So that's not actually part of it. So you can see that we're dealing with pressure and temperature only in this question. So we can just pick out those pieces of our combined gas law, which is P1 over T1 equals P2 over T2. And I can ignore the volume and I can ignore the moles. So I have 685 torr. Remember, pressure can be whatever as long as it's the same unit on both sides. But on my temperatures, I do have to add 273 because I need to have it in Kelvin. So I've got 273 Kelvin on this side. I'm looking for pressure 2, and I've got 423 Kelvin on this side. So remember, I'm going to multiply this diagonal, the diagonal that doesn't have the variable first, so 685 times 423, and then I'm going to be dividing by the diagonal where we do have our variable. So then I'll be dividing by 273. I'm looking for P2. I've got 3 sig figs here because that's the fewest number of sig figs that I have going. So I'm going to round my answer to 1060, and my units are going to be torr because my pressure units on the left side are torr. Whatever units I have of pressure are the same units of pressure I have on the P2 side. In example 4 here, if a helium-filled balloon has a volume of 3.4 liters at 25 degrees, that's temperature 1, and 120 degrees, that's, 120 kilopascals, that's pressure 1, what is its volume? So we're looking for volume 2 at SDP, assuming the number of particles is constant. So that's telling us N doesn't matter. We don't have to worry about N in this case. We see that we have a T1 and a P1 and a V1 and a V2. This, don't forget, is very important at STP. Whenever you see that, you know that you have 1 atmosphere of pressure and 0 degrees Celsius. Now, I'm kind of lazy. I don't want to do a pressure conversion as well. So I see that my P1 is kilopascals. I'm going to put this in kilopascals. Whoops. I'm going to make this one a 1.3 kilopascals. I know that 0 degrees Celsius is 273 Kelvin. Don't forget, I have to add 273 to all of my temperatures in order to get it into Kelvin. So in this question, I actually have 3 variables that are changing. I've got my pressure, I've got my volume, and I have my temperature. So that means I have to have the parts of the combined gas law that deal with those 3 variables. So I have P1V1 over T1 equals P2V2 over T2. So my P1 is 120.0 kilopascals. My V1 was 3.40 liters. And my T1 is 298 Kelvin. My P1 is at 101.3 kilopascals. Remember, I got to have the same units of pressure on both sides, and I was lazy. I didn't want to do a pressure conversion. I'm looking for V2, and I have 273 Kelvin down here on the bottom because I'm at STP. So you want to make sure that you multiply the diagonal where there is no variable. So I'm going to multiply 120 times 3.4 times 273. And then I divide by the diagonal where there is a variable. So make sure you divide by the product of these, or divide by each number. So I have to divide by 298 and 101.3. So how many sig figs am I going to get for this question? I get 3 sig figs. I'm not looking for T2 though, I'm looking for V2. So I get 3 sig figs. So my answer should be 3.69. And my units are going to be liters because that was my unit of volume on the P1s, or the one side. Okay. Next question. Here, I have a gas that has a temperature of 14 degrees Celsius, so that's T1, and a volume of 4.5 liters, that's V1. If the temperature is raised to 29 degrees Celsius, so T2, and the pressure is not changed, what is the new volume? I'm looking for volume 2. So which pieces of the combined gas law am I going to be concerned about? Which do I have to include in my equation here? The volume and the temperature. So I have to have V1 over T1 equals V2 over T2. Now make sure that you add 273 to your temperatures. Even if you're looking for a temperature and the first temperature is in Celsius, you always have to convert to Kelvin first, and then you would have to convert back to Celsius if it was asking you for a Celsius temperature. So that's 284 Kelvin. So my V1 was 4.5 liters. And I have 284 Kelvin. Over here, I'm going to add 273. So that should be 302. And V2 on the top. So again, you want to make sure you multiply by the diagonal where there is no variable first. So 4.5 times 302. And then you're going to be dividing by the diagonal where you do have your variable. So I'll divide by 284. And I didn't actually divide by 284. I should get for my V2, I only get 2 sig figs in this case because of the 4.5. So I should get 4.8, and my units are going to be liters because I have liters on the left side here. Whoops. Example 6, 2 liters of a gas is collected at 25 degrees Celsius and 745.0 mmHg. What's the new volume at STP? So I've got my V1, I have my T1, but remember I want to add 273 because I have to get this into Kelvin. And then mmHg is a pressure unit, so that's P1. I'm looking for V2 at STP, so don't forget that means 0 degrees Celsius, which is 273 Kelvin. That means 1 atmosphere of pressure, but I'm lazy, remember? So if I have my first units are in mmHg, I know that this is going to be 760 mmHg. So in this question, I'm dealing with pressure, volume, and temperature. So that means I have P1 V1 over T1 equals P2 V2 over T2. So my P1 is 745.0 mmHg. My V1 is 2.0 liters. And my T1 is 298 Kelvin. My P2 is 760 mmHg. I'm solving for my V2, and my T2 is 273 Kelvin. Now, if you do this in multiple steps in your calculator, you want to make sure you don't round until the very end. I'm going to multiply by this diagonal first, because you always multiply by the diagonal where you do not have your variable. And then I'm going to divide by this variable, and you want to make sure that you're doing this along with me to make sure that you are calculating correctly. And so I'm solving for V2. I do not use that 760 for sig figs because that is a constant, a standard value. So I need to look at my other values for sig figs. I have 3 sig figs total. So I'm going to round my answer to 1.80, and my units are liters because that's my unit of volume on this other side here. All right, last one here. A tire has 25 air particles. When it talks about particles, number of moles, that's going to be your N value. In a volume of 205 milliliters, that's volume, V1, and a pressure of 0.950 atmospheres, P1. If 10 air particles are added, so that's important, that's going to be our N2 to the tire, the volume increased to 215 milliliters. What's the new tire pressure? So here in this case, the temperature has remained constant. We don't have to worry about the temperature piece. So again, we're only going to pick out the pieces of the combined gas law that apply to the question at hand. So we have P1 V1 over N1 equals P2 V2 over N2. So our P1 is 0.950 atmospheres, and our V1 is 205 milliliters. Our N1 is 25. So we're looking for P2. Our V2 is 215 milliliters. Now for N2, do not put 10. It says 10 air particles are added. So what is our N2? Our N2 is 35. Just watch the wording. So when you calculate this, again, the diagonal where you do not have your variable goes into your calculator first. So you multiply this 0.950 times 205 times 35, and then you divide by the diagonal that has your variable. So I'm going to divide by 25 and 215. And I get, we're not going to use these air particles for sig figs because those are counting values. Those weren't measured, so those don't determine, or those aren't based off of sig figs. So we get 3 sig figs for our answer. So P2 rounded to 3 sig figs is going to be 1.27. And our units of pressure here are atmospheres because that's what they are on the left side of our equation. And that's how you do the combined gas law. So as you're practicing, if you have any questions about how to do this combined gas law, please reach out and let me know. All right, thanks.